Okay, so we're going to give it just a minute to let all of our attendees get logged in. All right, so thanks everybody for making some time this afternoon to meet with us for our second in our series of research seminars for the Inhealth Precision Medicine effort. We, as you recall, had a great talk last month about death data, and we're excited for another great talk today about medication tables. And we hope that this will provide a lot of really useful information for many of our groups. We're really grateful to have Michael Cook from the CCDA here this afternoon and John Scott from the TIC, who are going to tag team and go over some really helpful hints about medication tables. And with that, I think we'll start with Michael, who will give us an overview. And then John's going to give us a specific example or case example that he's been working on with a longitudinal viewer, I believe, effort. If you have questions as we go along, please put them in either the chat or the Q&A. And Ellen and I and Sharon will monitor those and make sure that your questions are asked and addressed in a timely fashion. And with that, we'll turn it over to Michael.
All right, well, hello everyone. Thank you again for having me. Let me go ahead and share my screen and I'll jump right into it because we have a lot to get through. Go ahead and turn this on to presentation mode. Come on. All right, so just to confirm, you can see my slideshow presentation.
Yes.
Yep, you're good.
All right, great. So let me go ahead and go into this. So first, a few things about me. So first of all is I do have a twin brother. However, as you can probably tell from the photo, we are fraternal twins. We are not identical. That is maybe one of the only photographed encounters of us wearing the identical shirt. We did it as a joke because I don't think we've ever done it before, to be honest. We're not the kind of twins who can get through that. And no, and I believe Sharon has asked before, he does not do coding, so he cannot come and join and be another Michael Cook for the CCDA, unfortunately.
Darn it.
Second thing about me, I currently live in Nashville, Tennessee, although I grew up in Elk Ridge and I've lived in Baltimore as well. I only just recently moved this past summer. My fiance is doing her PhD at Vanderbilt, and so we came down here. And then coincidentally, I'm wearing the same shirt in these two pictures, even though it's months apart. So I do have other shirts that I own, but these two pictures just happen to have the same shirt. And then my third fun fact, I do have a cat named Hiccup. She likes to type messages for me. I gave you a little sample of her text there. Sometimes goes on for a lot longer than that. That's a very small sample. And I have a picture of her there hiding just behind my keyboard. Just at the very beginning of this session, she was here in front of me, but she has since hopped down and gone and done something more interesting. But she certainly likes to help me with my work. Now, 3 things about the CCDA. So those were, more personal facts about me. Here at Hopkins, I work in the CCDA. So I think probably everyone on this call, I looked through the membership on the call. I think I've worked with everyone already, so you probably know who I am already anyway, but just to go through a few things about the CCDA. So first of all, we currently have 6 core members. I think that's down from the high of, I believe, 7 when I started back in 2020. And it was down to, I don't know, maybe 3 or 4 people at some point. So we've gone back up to 6, which is good. And I am the primary member on the team who works with PMAP, but everyone on the team does dabble in PMAP. So you probably see me mostly, but it's not just me on the team. I just want to make sure everyone knows that. The next thing is that we have projected over 100 PMAP projections. And as I add, this is why we cannot attend all standing meetings. I know that would be very helpful to everybody, but there would be literally no time for anything else if we went to all 100 standing meetings. And now, granted, this is not 100 PIMCOs or 100 PIs because there are many, E4MS projections. There are many PIs who show up in many different places. So there wouldn't be 100 meetings, but just so you have an idea of what we're working with here. And then finally, we have beyond PMAP, we have, I think, many more Clarity and EDW data extracts. And there's a small infographic here It's from before I joined the CCDA. It's pre-2020, so I don't actually know when this data comes from per se, but just to give you an idea of some of the other projects that we do. And those of you who have PMAP projects with us, I would say most of them fall in this 0 to 20 hours window. So you should be grateful that PMAP makes it a lot easier for us and for you, as opposed to pulling straight from Clarity or straight from EDW. All right, so let's talk about drug tables in PMAP. So first, one disclaimer is that I do not have any clinical background. I go to the doctor for a physical. The last time I was in a hospital was to get my COVID vaccine. So a lot of things that happen before the data gets into Epic and into Clarity, I don't have much of a background on. I've learned a lot of it in my role here at Hopkins. So just keep that in mind as we go through this. I'm going to be focusing mostly on PMAP and the data as it exists in the tables, just because that's what I know. And hopefully that will complement the knowledge that you all have, because most of you, I think, do have that clinical background and can answer things that I might struggle answering. So hopefully we can complement each other in that regard. Another thing I want to note is that we do have a PMAP data catalog for table info. And I can drop that link in the chat later on unless someone else beats me to it. And I want to bring that up because for a very long time, that was out of date. I think it was updated in 2020 and then maybe not updated again until a few months ago. But it is up to date now, and it is set up to automatically refresh with our derived tables. And so if you haven't looked at the data catalog in quite some time, please go back and look at it because it is up to date now. And then finally, a small disclaimer number 2 is that the next slide I'm going to show you completely comes from Carrie Smith. So thank you to Carrie. So let's go to her slide. This is an overview of the medication tables in PMAP. And luckily, all of this is pretty much the same. Like 98% of this came from Carrie. I changed like 1 or 2 things that had to be updated. So first of all, on the left, we have Clarity medications, what we refer to as, I guess, the mother table. This is where pretty much all of this other data flows from. It is a dictionary table, and so it's not going to show you, for example, patient 1 had this medication on this day. It rather lists all of the medication records and information about them. And I am going to come back to that idea of a dictionary table in a little bit. Also has unique medication IDs for the specific formulations of a medication. Also information about pharm and therapeutic classes. And again, this stuff is more of the clinical stuff, so not stuff that I know as well, but I'm sure that you all know exactly what all of this means. And thank you again to Carrie for putting this together for me. And then on the right here, we have all of the different tables in PMAP that depend on this table. And this is really where I know more what I'm talking about. And we're going to go through each table in more detail, so this is just a very brief overview. So first, we have the derived med orders table, all medication orders placed by Johns Hopkins doctors, and this also includes patient-reported medications. We have med order components. This is information about individual components or ingredients of mixed medications. We have PAT encounter current meds. This is a record of medication reconciliation, which is basically what medications patients are taking or not taking recorded at each encounter. We have the derived med admin table. There's also a derived med admin all table. Those are both the same thing. One just has the duplicate rows removed. This records administrations of medications to patients in an inpatient setting. So this comes from the MAR. And this is Carrie's slide. I'm not sure what the asterisk was for. So I think it was something she said when she presented this. So unfortunately, I'm not sure what she added on here. Treatment plans order apparently didn't get a bullet point there. I apologize for that. That is one of our newer derived tables, and that pulls in information from Epic treatment plans. And then finally, we have the RX norm codes table, which can be found in the PMAP dictionaries projection because it is a dictionary table, which leads me to, oh, and there it is. Apparently it was out of order. So let me talk about the PMAP dictionaries projection. So this is something that was projected relatively recently with little to no fanfare. I think most people might not even realize that this is here. I didn't even realize it was here. until recently. It had already been in existence for a few months. And so this is a database you can see in the screenshot on the right here. This is a database which is available to all users of PMAP. If you have access to a database on PR4 or PR5, you can access this database as well. And this is made up of a bunch of dictionary tables. So like I was saying before, that Clarity medication table, here's some sample data from it. Again, it's not showing you what patient had what medications. It's just telling you for medication ID 171727, it refers to this name of the medication, this therapeutic class, etc. And there's lots of very helpful tables on here. And so if you haven't looked at this database or these tables, I really encourage you to do so. There's a lot of really useful information here. At the very bottom of the screenshot, there is a flow sheet measure dictionary table, which could be very useful for teams who are trying to figure out what flow sheets they want us to project for them, because that's always a tricky part for teams. So if you haven't looked at that, feel free to give that a look. This is available to all PMAP users. All right, so now yeah, go ahead.
Well, I had a quick question from
Sure.
the crowd while you're on the tables. There was a question of, are any of those or all of those available in OMOP format? Do you know?
The dictionary tables or the medication tables?
The medication tables.
So the medication tables, and I don't have this in the slides, but I can go over it at the end if there's time. There's basically just one OMOP medication table called drug exposure. And luckily, OMOP is very well documented, as it's a global community-based organization. And so I can share the link for it later. You can look up the schema for that table. And I will tell you, let me go back here. For OMOP right now, we're pulling in, if I remember right, the derived med orders table and the derived med admin table to build our OMOP drug exposure table. And then, of course, using RX norm codes for the vocabulary. I don't believe it. I'd have to double check, our whole ETL code to be sure. I don't think we use med order components, pad and counter current meds, definitely not treatment plan orders to build the table. So you can keep that in mind as we're going through it. Derived med orders and derived med admin are the main tables that are used to build the OMOP table. Were there any other questions I should answer right now?
I think you're good. Thanks.
Okay. So now I want to go through each table that I talked about in more detail. So first is the derived med orders table. So this is one that contains the EPIC medication order information. And this comes from either outpatient or inpatient settings. However, if you look at the number of encounters in the table, it's about 70% outpatient encounters. So primarily that's what you're going to be using this table for, is looking at outpatient drug orders. It does not contain information on dispensed medications. So that is something to keep in mind. Orders with provider ID 699907, you write that down. Though that refers to patient-reported medications. I believe that provider is like JHH historical. So that refers to patient-reported medications. Oftentimes, those rows will have a null start or end date because the patient says, oh yeah, I took whatever medication, but I don't remember when I started or I don't remember where I ended. And so those will just be put in as nulls. And that's a question I get often is, why is there a null start date for the medication? It's usually because it's patient reported. And then also something to keep in mind with this table with patient reported medications is that specific selected drugs can be close to what the patient described, but it might not be exactly what they were actually taking. So just keep that in mind. And then over here on the right, I'm going to do this for all the tables we go through. These are just the top 10 drugs that appear in the table by total count. And I'm not going to go through each one here, but hopefully those of you with the clinical background kind of spot check this and think, oh yeah, that makes sense. And you'll see as we go through that there is a lot of overlap, but there's also some differences between the drugs you see in the different tables. So that is the derived med orders table. Let me go on to the next one, derived med order components table. So this contains ingredient medication information for mixture orders. One important thing when you're working with this table is do not mix up the medication ID column and the original medication ID column in the table. Typically, that medication ID column is referring to the ingredient, whereas the original medication ID column is referring to basically the dispensable product, the overall mixture, you could say. And I did also check, and a lot of times they actually end up being the same exact value in both columns anyway. But it is just something to keep in mind that when you're working with this table, you should keep that in mind. And also, I forgot to say before I started going through these tables, I'm not going through all the different columns in the tables, just because we have, now that the PMAP data catalog is up and running, you can search up the tables in the data catalog, and that's probably going to be a better use of our time here. So over here on this side, I have, instead of the top drug by just total number of drugs, I did something a little bit different for this table. I did the drugs ordered by the number of ingredients per that per each drug. And so you can see that there's some very interesting things in this table. Again, as not a clinical person, I'm assuming this IV builder JHH, for example, is some kind of template that people can put their own mixtures into for certain scenarios. So for example, my IV builder JHH might not be the same as your IV builder JHH. I mean, who knows? Maybe it's a mixture of 272 different drugs, but I'm assuming that's not the case. So that is this table. It's very useful for teams when they want to look at the different ingredients making up a mixture order. Next, we have the derived PAT encounter current meds all table. It is quite a mouthful, and it's also a bit of a controversial table for anyone who had a Crown subprojection, which was COVID data back in 2020, 2021. You might remember that we had said at the time that this table was broken and we weren't projecting it. So if anyone encountered that and you got traumatized, this table is no longer broken. This table is up and running, has correct data. So just know that this table is working again if you remember that. It is based on the EPIC Clarity Table PAT encounter current med. So it's not as processed as some of our other drug tables. This reports on current or active medications at the time of each encounter for each patient. And this leads to a lot of repeat data because every time the patient comes in for an encounter, whether inpatient or outpatient, they're going to record the medications that patient is on. And that could be a lot of repeat data. For example, if you look over on the right here, the fifth most common drug reported is a multivitamin capsule. So if someone takes a multivitamin, I mean, I take a multivitamin every day. Every time I go and have an encounter, it's going to record that I'm taking a multivitamin. And so because of that, we generally do not project this table unless a team has a specific need for it, just because there's going to be a huge amount of data that's mostly redundant. And most of the time you don't need it because you can get the information from other tables, depending on what exactly your research aim is. And over here on the right, we have, again, the list of the top 10 drugs by the number of encounters they appear in. So you could kind of call this like the list of the most common drugs for patients having encounters in the Johns Hopkins medical system. So it is kind of an interesting list. And again, hopefully those of you who are clinical can kind of spot check this and think, that makes sense. All right, so I believe that we're halfway through now. So this is the derived med admin table. And so remember, along with derived med orders, this is the other primary source for our OMOP drug exposure table. And this is also, I think, a very highly sought after table as well. I don't think we count this as a foundation table now, if I remember right, but pretty much everyone gets it anyway, because pretty much everybody wants this information. This contains any medications administered during inpatient visits. And so these are not just orders placed. These are not just medications prescribed. This is specifically medications administered during a visit. It tends to be a very large table. And so we do require filters if you want this table projected to your database. But again, any older PIMCOs who have been grandfathered in, you may have received the entire table. But going forward now, we do require filters to be placed on the table just because it can get so large. And one thing to just note here that's very important, since this is looking at, again, medications administered in an inpatient visit, the accuracy of the data is highly dependent on the department where the medication is administered, whether they put in the exact date and time it's administered, whether they put it in the next day, if they put in the exact medication. So that's just something to keep in mind. And again, on the right, we have the top 10 medications administered. Sodium chloride seems to come up in all of these tables, so I guess that's way more common than I realized, but I guess that makes sense. All right, next we have our derived treatment plan orders. This is one of our newer derived tables. It's based on Epic treatment plan orders. There's also a table just called derived treatment plans. It's a very similar table. You can pretty much use either, but this one has more of the exact order information in it. This is a very messy table, especially if you're trying to use it for drug information. For example, there's no discrete drug ID field, so you can't programmatically go through this and pull out all the drugs a patient had, for example. You kind of have to pull it out from the name of the treatment plan. And you can tell just looking from the list on the right that this is kind of messy. Number 2 is hydration. Number 6 is also hydration, but just capitalized differently. And so you do have to really know what you're doing if you want to use this table. I would only recommend using this table if you have a specific treatment plan or treatment plans that you know of, and your research is dependent upon knowing which patients were prescribed that treatment plan. So it is a very messy table, and I wouldn't recommend it for looking at drug information in general. And then finally, back to our derived RX norm codes table. So this, as I said, is used as a dictionary table. Again, it's not going to say what patient had what medication when. It's just going to give you information on the vocabulary of the RX norm codes for the different medications we have. You can see the different possible values for the code level, med only, med form strength. And then you have your different RX norm term type, whether it's brand name, generic, ingredient, etc. And again, to be honest, a lot of this doesn't mean much to me. I'm hoping that those of you who are more clinical and use this more often might make more sense to you, but it is very important for things like the vocabulary, especially looking at when things get mapped into OMOP. But luckily for me and for you, a lot of that happens behind the scenes. And again, this is available in that PMAP dictionary's projection, so you don't need to request this table. It's available in everybody's, it's available in everybody's, not your projection. Everybody who has a projection can access this on the server. And this could be helpful if you do have an OMOP data set or you want to get one eventually. RX norm is considered the standard vocabulary for drugs. And so if you want to do any kind of OMOP work, whether it's an atlas or it's in your actual OMOP data, you would probably want to use this table to translate your drugs from PMAP, the medication ID, to OMOP, the RX norm code. So that's just something to keep in mind there. And I think I'm just about at time, which is good because I have this slide and then one more. So I have a few other considerations about medication data. So a few limitations, and I put this down at the bottom, but this list of bullet points again comes from one of Carrie's slides. And the first one here is she says there's no dispense data at this time. And I'm not sure, to be honest, if she meant just the OMOP table or if she meant overall. To be honest, again, I think this is a clinical term, dispense data. To me, as a non-clinical person, I think anytime you get data or anytime you got medications, it get dispensed to you, right? But I'm assuming this is a specific Epic workflow that I'm not knowledgeable about. And so my next slide is going to be a question I have for you. It's different than this, but my unofficial question is this accurate? What exactly does this mean as a non-clinical person? A few other considerations. This excludes pending meds and empty order dates. This is obviously limited to your patient cohort for each PIMCO. So the counts that I was showing, to go back a few slides, this is for overall, the derived table overall. If you run your own counts for your own PIMCO table, you might get different counts because you have a very different population. The medication information is not comprehensive. There might be missing information about the different classes or the RX norm codes. Custom meds, and this is another one that came directly from Carrie. I'm not sure what FDB is. I'm not sure if I'm being stupid and it's something obvious everyone else knows, but I'm not quite sure what she meant by this. But custom meds are cloned from FDB and won't have metadata. So just something to keep in mind. I hope that someone knows what FDB is, because I'm not sure what this means. And then final word of caution, be careful how you join the tables. So again, I didn't go through the schema of these tables just because it's in the data dictionary, but just remember that they can be joined on the patient level, on the order level, on the medication level, on the encounter level. So you have to make sure you're using the correct fields when you're joining between these tables, because you might get different results and different counts depending on what you do. All right, and I will leave you with this. This is my question for you all. So regardless of the reality of these drug tables, as I've shown them to you, how do you want to use drug information and PMAP for your research? And is the reality that we have, are these tables sufficient? So please let me know, especially if you can fill me in on any of the clinical things that I'm missing in my background. My email is there. Thank you all. I will pass it off to John Scott, unless Lori or someone else is going to come back on first.
Yeah, we have a few questions for you.
Yeah.
Well, some of them I think John may cover, so we won't answer all of them right now. One question is about medication dosing. Is there a column in any of these tables that provide the dose? For example, 40 milligrams, 100 milligrams for the particular medication?
Yes, yeah. Usually the derived med order table is the best one to go to for that. They do have a specific dose field. One thing that's a little bit complicated is that dose, well, two things. First, dose and unit are separate columns. And so dose will just say 40, and then the unit will say milligrams, for example. So you need to look at both columns to get it. Another complication is a lot of times, not a lot of times, but often those fields are not populated. And instead the SIG field says, take 2 40 milligram tablets orally each night, for example. And sometimes you have to look there for the information, which of course is not discrete and you can't programmatically go through that. So it is there, but a bit of a caveat.
The next question is data from SureScripts in the derived patient encounter current meds table? And if not, is there any plan to add it to PMAP?
I'm not sure what SureScripts is. Is that something within Epic or is that an external source? I don't know if you know, Lori.
I believe that's an external source. And so
Okay.
the answer is probably no, would be my guess.
Yeah, the answer would be no, as far as I know, especially that derived pat encounter current meds table is more or less based on that Epic table, it's the Epic Clarity table. So as far as I know, we're not pulling in an external data source, but I could be wrong about that.
Okay, we can get back to you about that answer. There was a comment from Ali Strauss, thank you, that we believe that the dispense means that we just don't have data about when the medication was filled at the pharmacy or dispensed at the pharmacy. So we are able to see that as providers in Epic. And so that may be why people ask for that. And is it available in PMAP?
Got you. Yes, thank you for clarifying that, Ali. And you are correct. We definitely do not have that available, at least not right now. And I don't know if there's plans to make that available in the future, but you're right, that is not available. So thank you for clarifying.
And another of our attendees wants to know how much availability the CCDA has or can provide with cleaning and tidying up these tables.
Yeah, it depends on what exactly you need. If you just need your table filtered, for example, we definitely provide filters when you get the data sent to your database. But if you need anything more complicated, usually we recommend going to the bead core or the biostats team because they can do more intense analysis for you. We can probably offer like suggestions, insight, but just as a team, we don't typically have time to do very in-depth analysis. But base level things like simple filtering we can do. And then if you mean, and that I'm assuming that meant the data once you get it. If you mean kind of behind the scenes, like from an ETL perspective, that's definitely something that we work with a data management team, and we're a lot more involved in that. And so if you think there's any issues with the workflow, with getting data from a certain spot in Epic into a derived table, that's definitely something you can bring to me or someone on my team or the data management team. And we work closely with them to get those changes made.
Okay. With that, I think some of these additional questions I think will be addressed during John's talk. So John, we'll turn it over to you.
All right. Thank you, everybody.
Thank you, Michael. Okay, let me share as well. I'll make sure okay. Let's go to our slideshow. Okay, is it presentation mode over there? I've got two screens. I'm never sure what's showing on the other end.
Yeah, I see the presentation mode that has like slide 1 through 24.
I think we have your presenter mode
You
there.
see my presenter mode. Okay, so let me stop the share. I'm going to switch to the other screen. Sorry, share. And let's share this screen. We'll get to see yourselves first. Okay, can you see the presentation now?
Yes, you're good.
Okay, okay, great. So first, who am I? I am a director, a unit director at the TIC. That's the Technology Innovation Center, and one of the things that we do is work on PMAP. Some of you have worked with me. 3 things about me. I'm a father of twins, so we've got something in common with Michael. I don't have any pictures because if I did, my daughters would kill me. I'm also a husband to Samantha Pitts. She's PI for the Adult Primary Care COE. And I didn't start as an engineer, as a software engineer. I started as a literature major and a bookseller. And I got a computer connected to the University of California library, and I thought, wow, this is just like a bookstore. And I started bookstore.com in 1996. And since then, largely just software engineering. I work for the TIC, and we do much more than support PMAP. We support all things JED. The primary focus for everybody out there is MyJH. Everything we do through MyJH goes through stuff that we built. We built Chorus, and before that Ping, which handle secure communications between doctors. We built lots of different apps. EpiWatch, which is a wearable Apple Watch epilepsy tracker, VMS to track vaccines, HBO. A lot of things that you use every day were built by the TIC. We also lead a lot of efforts in UX design at Hopkins, and many of you have talked to or worked with Jasmine McNeil, and you know how great she is at that. And then, of course, we don't just code and we'll just do that. We do all kinds of other things. There's a big group of bicycling enthusiasts. We've got divers, people climbing, a lot of musicians, and we have regular sessions called the TIC Talks, TikToks, where people share their hobbies and interests with the rest of the group. So the agenda for today. First, I want to cover, actually, first I want to ask, does everybody see a little screen? I'm going to move something out of the way here just a moment. Okay, so our agenda. First, I want to cover, what do we want to know? What is it that you want to know? What is it software engineers want to know? I have changed the agenda. I've moved that patient insight hypertension thing to the end. So please note that that's going to come at the end. I want to discuss our data sources, how we form a data dictionary to deal with our medications, how we define start and end, and finally, just some thoughts on the accuracy of the data. So what do we want to know? So when Lori asked me to do this, she sent me this question. How do I determine which inhaled steroids my asthma patient has used? When did they start? When did they stop? Can I know this for sure? And I think this pretty much encompasses what most of the COEs that come to Patient Insight want to see. They want to know this in a nutshell. And you know, it's a very concise, very nice question there, but it gets a little complicated when you start to get under the hood. As Michael said, essentially, this is what was the patient's drug exposure. And I won't presume to tell you what that means. That's your area of expertise, but I will sort of focus in on a couple of things. It says drug exposure is inferred from clinical events associated with orders, prescriptions, written, pharmacy dispensing, procedural administrations, and other patient-reported information. For example, the prescription, the medication list, prescriptions, and drugs administered as part of the procedure. This came from the OMOP Common Data Model Specifications book. And I want to stress this because our data is coming from various places, as Michael pointed out, and with varying degrees of information and inconsistent structured fields. And what we want to do is we want to present this as best as we can, but I think we do have to understand that there is some wiggle room on this, and information has to be processed through a clinical eye. So what does the software engineer want? I want to know, where does the data come from? How do I get to it? How do I identify the records in question? In this case, Lori's question, inhaled steroids. How long does it take to get that data? I need to present something. I need to present something in real time. You don't want to wait 30 minutes for an answer. What attributes of those data do we want to capture? Does the data need to be filtered, validated, shaped? And finally, how do we identify the patient? The last one is pretty easy for the COEs. This is determined by your cohort. Your cohort defines the patients that are displayed in Patient Insight and whose data we're going to retrieve. So data sources. For Patient Insight, and before I sort of get into the data sources, I don't know that everybody knows what Patient Insight is, but Patient Insight is a dashboard to display patient longitudinal history. It's curated by condition. Generally, that maps to a COE, and it's an application external from Epic, but you can use it and see it inside Epic using what's called a smart on fire workflow. That means that Epic calls out to our application, it authenticates and passes context to it, and then is displayed in hyperspace in a panel. But I want to stress that it is not Epic. We get data out the back door. Where do we get the data? We get the data from PMAP. PMAP can send us projections, or we process data through an ETL from PMAP nightly and pull data from your COE registries, in some cases some other sources. And that is sort of batch process data that comes out to us. We run it through some transformations, turn it into what we need. We filter it, we validate it, and we end up with data that we can actually display. It's keyed on that medication ID that Michael mentioned. That is the internal ID for all medications in Epic, in the Clarity medication ID. I will say, however, that data in PMAP is at least 48 hours old, because it goes through a multi-stage process to get to you and then get out to me. It can be more. For some COEs, that data may be up to a week old. So just note that data is not up to date. That's fine for research, but not for clinical decision support. We also get data from FHIR medication statements. FHIR is the Fast Healthcare Interoperability. I can't remember what the R is for, but it's a protocol and a schema for exchanging healthcare information. And it's a mechanism by which we can query Epic in real time and ask for specific information. For medications, we pull the medication statement resource. They've got lots of resources for different kinds of medical data, and there's other ones for medications, but we pull medication statements. It's sort of equivalent to the derived med orders table. The reason we use the derived med orders table and the medication statements is because it includes orders and patient-reported data, as well as some administered orders. So it's the broadest area, or it covers the most ground on the medications. And for our use cases so far, most everything that we need. So FHIR, again, is keyed on RxNorm, which you heard about. It's real time. And then some of our COEs use data from other sources. Multiple sclerosis has data in smart forms, so does myositis. Scleroderma has it in REDCap. All of these data come in and we sort of harmonize them and put them together. In some cases, like in myositis, we will join the smart form data with Epic data. In case of multiple sclerosis, we're sticking just with the smart form data, and with scleroderma, we're looking at harmonizing the REDCap and the Epic data as well. So just to say that we've got multiple sources of data, and I will stress these data may be one and the same in Epic, but when they come from different sources, if it comes from PMAP through the process of going into PMAP through Alpha Chronicles to Clarity to the derived tables, and how we get it from FHIR is distinctly different, and the schema are different, and the labels of things are different. So we do have to do some harmonization to get that data back together. So why PMAP and FHIR? Again, FHIR is real time, but we have limited filtering on the query. This means that we've got just very few options. We can ask for the status of the medication. Is it current, or is it active? Or we can ask for all of the patient's medication data, but that actually crashes the system. As you know, there'd be so many different things in there. Every aspirin they took, it's massive, and everything times out, it doesn't work. FHIR also uses these standard vocabularies, RX norm, but fact is that there's a lot of medication history in Clarity that does not map to RX norm, and you may have found that already. Michael already said that when it's patient reported, they'll enter the medication that's closest to what was said, but sometimes doesn't map exactly to an RX norm vocabulary. So there's data we can get directly from Clarity that is not so easy to get from FHIR because we have no way to really identify what it is. So the PMAP derived tables are comprehensive. I thought about it. It's not really comprehensive, but it's closer. There's a lot more there, but the data is old. So when we combine both sets and harmonize them, we can get a full picture or a fuller picture again of what the medication history is for this patient for a particular condition. Which brings us to a data dictionary. Michael already presented data dictionaries there that define what do medications mean in EPIC. So what are all the mappings of these medication names to IDs? How do they map to RX norms in these tables? But what I'm talking about here is a dictionary that defines something a little bit more specific. Now, you remember Lori said she wanted to know which inhalable steroids her patient was taking, right? And so we need to class our medications and pull it down. Now, the first data bank the FDB that Michael had referred to does have a column for therapeutic class, pharmaceutical class, and pharmaceutical subclass. And this is an ontology that will help you map down to these medications that you want. But we found that it did not actually pull out everything that we wanted. And so we followed on the great work that Carrie Smith and Brent Chi have done and went to the NIH RX nav and RX class site. Now, this maps all kinds of different UML, codes, standard vocabularies to medical terms, and for medications, we're using it to identify RX norm codes. To do this, we ask the PI to identify the ATC classes. These are the WHO classes, and the EPC classes. These are the FDA established pharmacological classes for these medications. We then use the API that's exposed by this site to pull all the ingredients and the RX CUIs. These are the ingredient RX norm codes for the active ingredients that are used for those particular classes. We then use those RX CUI codes to map in that RX norm mapping table that Michael presented to find all the medications in the Clarity database, the FDB database, that match those RX CUI, so we can identify here is a set of specific medications that will roll up to, for example, calcium channel blockers. And we found that was not necessarily complete because some things did not have RX norm codes. So we further supplement this by doing some regular expression word matches on both the name and the generic name of the medication to see if we find other medications that have that ingredient in them. This requires some level of curation. First off, obviously, we need to identify what these classes are, and we depend on the clinicians or the researchers to do that. Then the resulting ingredients are also eyeballed to make sure that they are what we're looking for. And then finally, we think that we do need some curation of the results that come back by string search as opposed to the RX norm search to make sure that the identified medications there are what we want. So just taking a quick look, this is the RX class page site over on the over at the NIH, and you can search down through their class browser to find the classes that are of interest. They've got the API. This is what we're using. This is a slide that shows the different APIs that are exposed. And an example use case, we want to find all the ingredients for CCBs. So we identify the classes. We then use the RESTful API to get the ingredient RX CUIs. As I said, we then search through the FDB for all the medications that match to those RX CUIs, and then we identify additional matches using the string search. Our example here is for calcium channel blockers. The ATC class is C08. The EPC class was N00019382. And these two links here, when you click on them, they bring back all the ingredients that come back from that. We take those two sets of ingredients and we get the distinct values of it. And here we've got a list of the ingredients that were returned. You can see here there's two queries that we did. And when we pass this through the pharmacist, Amanda, who's working with the Adult Primary Care Center of Excellence, she indicated that this last one, and forgive me if I mispronounce it, zigonotide, was not indicated for cardiovascular use, so we removed that. Next stuff is SQL for you, those of you that like it, that's great. But basically what we're doing is that first part where we're just identifying which medications in that database, in the dictionary database, have that RX norm code. And we're also pulling another RX norm code, the SCD RX norm. This is the semantic clinical drug code. And this is the RX norm code that we use to map to FHIR. That'll map to the particular formulation that has been prescribed to the patient. As I said, we also do a search on string ingredients. So here you've got another little query that does some regex to find medications that have that ingredient in the generic name. There's another one for the name of the medication. And finally, we end up with a dictionary. We got a dictionary that's got the semantic clinical drug RX norm code over here, the name of the medication ID in EPIC, the ingredient that we use to map it to that particular group, the ingredient RX CUI, and our med group here, the grouping that we have. So the next part of that's that first part of Lori's question. How do I identify what drugs? And we'll use that now. If we know the cohort, we know what medications we're interested in, we know what patient it is, we can query the med orders table to find out all the times that particular patient took any of these medications. So the next question is, when did they start and when did they stop? And again, Michael covered a bit of this. And so as he said, patient-reported ones may not have a start date. I'll actually further qualify. They don't have a start date. But they do have an ordering date time. So what we do is for start date, we take either the start date, and failing that, we take the order date time. So this will give us the point in time when that medication started to the best of our knowledge. Again, patient-reported ones, that date is soft, it just depends on their memory. In the case of when we're gathering data in REDCap or in smart forms, it may be even softer. For multiple sclerosis, for example, we know the month it started, or maybe even just the year when it started. So anyhow, I just want to say that these dates aren't necessarily precise. If it was administered, they know exactly when that medication was taken. So I'm saying the order of medications have an end date, but after that it gets complicated. For the end date, we take the discontinued time. If the medication has a discontinued time, in other words, somebody's indicated it was discontinued, we will take that over the end date if available. If the patient is deceased, and this is something that we're still sort of shopping out to people, whether that should in fact be the end date, because the end date, if it's the original order end date, it may continue into the future, and this can be a little bit confusing when we're presenting a longitudinal view. And then, of course, we may not have an end date, and sometimes this isn't clear. It depends on the medication. Maybe this was just one, something that was administered or injection. It came once. We don't have an end date, so we don't know. So some of this data falls out when we're going to go show it in a longitudinal view, because we do not know when either the beginning or the end date is. As it is, I think we're capturing most of it. But I just wanted to be clear that there are cases where we can't. Okay, so again, just on what I said there, that the order medications have a start date, patient-reported ones don't. and that we use discontinue time over end date, and we are discussing whether to use death time over discontinue time if available. I know that the kidney COE has their own process for identifying medications, and their logic is a little different than this. They choose to infer 365 days from the order time if they don't have an end date, but they could explain that more. That's because most of these medications, if an order will only last for a year. But again, end date is sometimes not entirely clear or available. So with that, I'm actually going to close. I'm going to drop out of this and go to Patient Insight to show you what this looks like. And let me switch things. Can you see a screen that shows a website at this point? Lori, we good?
No, we're still seeing
Yeah, not yet.
your
So
slide.
let me stop the presentation here. Let me come back to my I'm going to stop share a second and come back in and share.
It's the issue to many technical problems. Stop and start again.
That's right. That's right. I'm gonna escape. Sorry, I'm gonna escape from the PowerPoint. It was not so easy to do within the thing. Okay, escape. Okay, and I'm gonna share again. This time I will share that other screen. Okay. Can you see my screen again?
Yes, now you're good.
Okay.
Yep.
So, Lori, let's take your example, but let's do it with the hypertension cohort here, which we've worked on to do just this. And I'm going to zoom in a little bit here, just so we come to the medications. So let's say the question is, when was my patient on ACE inhibitors, and when did they stop? And what you can see here is, well, they started in August 2nd of 2018, and then stopped in October 26th of 2018, and then started up again in April of 2019, ended in May of 19. For the CCB, for the calcium channel blockers, again, we've got something. When we open this up, we can see that we've broken it out by ingredient. Remember, we're mapping to our groupings by using this ingredient. So we can see that lisinopril was what they were using at these various points, and then they switched to captopril. We can break it down further and say, whoa, okay, let's see what lisinopril. Now, this is where it gets funky. All those medications in there in EPIC and the Clarity database have long name that covers a different formulation. So this lisinopril here, the first one says that it's lisinopril Zestril 20 milligram tablet. And if you look at the next one, it looks like it's the same thing, but if you look at the end, it says tablet 20 milligrams. And a lot of times we have this problem is that these things are different. They've got different medication IDs. They've got a slightly different name, but when you look at it, it is largely the same thing. We haven't, for one of the asks that we have is to show like the changes in dose on a particular medication. And as Michael pointed out, that is easier said than done. So what we've tried to do is break it out by ingredient, so you can at least see some continuity on a particular ingredient over time. You can hover over these or click to get more detail about it and see that from August 2nd to October, this is a particular order. They were taking this particular formulation. The route was oral, it was daily. These are all the different attributes that we've extracted on that medication from EPIC. But in some cases, the information is, dosing information is hidden in the SIG. This was pretty straightforward, and we can see that it says daily. It has a route, frequency, a dose of 20 milligrams. But it doesn't tell us necessarily. It tells us 30 tablets, but we don't necessarily know that they had to take one tablet. It might have been two and hidden in the SIG. So dosing is something that is difficult for us to extract in a programmatic way. Actually, so just to go for Lori's question, we're still working on the asthma one. But they do have inhalable corticosteroids, Lori. So here we can see that this patient started in December 24th of 2014, and they ended in December 13th of 2023. Okay, so I am going to hop back to my slides here. There's not much left, but let's see. I hope I bring up the right one here. Okay, and I will share, oops, you know what? I'm going to put this over on the other screen because I think my presentation mode, you know what? We don't care. I think we can just look at these last slides as is. The question then, the last part of Lori's question was, you know, how do I know? How accurate is the data? And again, I'm going to just go over the information that Michael shared. So the data is only as good as the input. You know, obviously with administered medications, we have a high confidence that that medication, that the patient was exposed to a particular amount of some ingredient. For ordered medications, well, we've got a little bit lower confidence. We know it was ordered. We don't know if it was dispensed. We don't necessarily know what the adherence level of it is. In some cases, I know that multiple sclerosis, REDCap may be capturing that as a discrete field in their smart forms or in REDCap, but that's not necessarily clearly structured in the EPIC medication data. For the patient reported and historical ones, and I do think that we do get feeds from outside and that they do come in and they get merged in, they've got a different provider ID, but we're not really sure. As I said, we do our best to pull some of this stuff out, but my intent at our end is to get the data as close to what is an EPIC out to you. So in some cases, we make some assumptions about like the start and end date, but we do not want to go further than that. We do not want to parse out the SIG. We get into you know, diagnosis level of parsing there when we don't want to do that. So other things to consider, you know, if that medication is patient ordered and it was entered, was it mapped to a known RX norm code? In some cases, we see, for example, you know, somebody's on lisinopril, but it says that they were taking bulk lisinopril powder. Well, obviously that was a mistake. It was entered incorrectly. Somebody selected lisinopril in a drop down, and that's what went in. But they're not really on bulk lisinopril powder. Obviously, are there notes and the SIG? So on that, I will just say that my question, which I don't have here in a slide, is how do you think we should determine as a community what we should display for start and end, knowing what you know about the data that we have here about the start and end date. The end date in particular, I think the start date we can be fairly confident about to a degree as to what was put in, but the end date, what should the end date be? I think discontinue over end time seems clear enough. Death date over the two other ones seems like it's logical. But if we don't have a date, do we say it ends today? Do we not show it? Do we put it out to a year from start date? I want to stress that not showing data is also a form of information. And if we don't show the data, we may assume that something's not there. So we're still trying to figure out the best way to deal with some of these uncertainties. And with that, I will stop share and I will open it back up to Lori.
All right, thanks so much to Michael and John for your great insights today. We're a little bit over. I'm going to ask just a couple of really quick questions. One, and I think you sort of went over this. If you're if you're creating a real-time application from PMAP or derived from PMAP, do you need a different workflow or format because the data is not real-time? How close to real time can you get with PMAP now?
Well, so PMAP is an analytic platform for doing your research on, right? Patient Insight is a tool, a clinical decision support tool, which relies on insights, if you will, that we get from PMAP. So research is done from PMAP, and you may determine in PMAP that you're interested in these particular metrics. That these are the metrics that define a cohort, that these are some algorithmic results that you want to apply to some metrics to do something, right? So I think there's a distinction between PMAP and what we can figure out there and what we need to do for clinical decision support and using out there. So so the next part of that is, yes, there's different formats, and the data, as I pointed out before, even if the data, the original data is all in EPIC, the route that data takes changes it some. The format of that data is different. So there is some degree of having to redo it and rethink it. You know, okay, I've identified all these things here. Now I figured out some pattern or something that's of interest to me. Now I need to apply it over here, and I need to make sure that I'm pulling the same things over here to apply it to. So there is, and in model development, this is called, I think, training inference. It's not drift. I can't remember, but there's a term of art for the fact that your training data, what you're doing for research, may be different, has gone through some level of change, and it's different from the data that you're getting live to answer a question at the point of care.
Another question is, I guess I'm not going to say this right, RxQEs cached?
Yeah.
So we have a growing list of the ingredients to not have a large number of REST calls.
So the REST calls, well, it depends on what we're talking about on the REST calls. So to figure out what our data dictionary is and pull it in the first place, we'll persist that list, right? And what my hope is that we can start to come up with, and these can also then map to OMAP concept sets, since OMAP uses our Rx norm for it. If we define let's say ACE inhibitors, right? Here it is. It's a dictionary that we can then reuse. If we define steroids, here's a dictionary. But you know what? This particular use case may need a sub-dictionary from that. For example, PEDS may have a different, may need to subset that or add to it, right? So we can develop these things and cache them. Now, for real-time queries, we're asking for when I ask for medications for a particular patient, I say, I've got a patient, give me the medications for this patient, right? And then I say, or actually ideally, the FHIR spec does say that we can query by Rx norm code, but it's not currently implemented in Epic, right? So but as it goes down the line, we should be able to say, Epic through FHIR, I've got this patient, give me all the medication history that you have for these Rx norm codes. So in that case, I don't know that we can cache it. We're asking specifically about this patient for this time. So I'm not sure if that answered the question.
I'm not sure either, but hopefully. I think it is a great question, though, to think about. Can we build I don't know, code repository, or because as we all of our different groups go through asking very similar questions about our medications, can we reuse code and insert different Rx norm codes or whatever, so that I can use very similar language for my inhaled steroids that Sam is using for her ACE inhibitors, for example.
Yeah, that's our intent. Our intent is to start to streamline this and save these sets and then refresh them at regular intervals, so that we just go out to the NIH, refresh, run it through everything. So refresh these dictionaries at a regular interval, and then decide what level of human curation has to happen and at what level, right? And certainly if things have been subset, what has to happen there.
Yeah. All right. I think we are out of time. So thank you to everyone who attended, and thanks again so much to our speakers. We may have to have you back for a Med Tables Part 2 in the future, because I think there's a lot of question and discussion about this, and it's a really great topic. For our attendees, we will be sending out a link with the recording to this video, and it'll be archived so you can review the presentation again. I know that was a question people were asking. Boy, we'd like our data managers to be able to watch this, and so we'll make it available to everyone. Ellen, do we have a topic yet for next month?
Our tentative topic is discussing the social determinants of health. So we'll send up an update, though, to confirm that is the topic and to confirm the time. Thank you.
All right. Thanks, everyone. Have a great evening.
Have a good one. Thank you.